Hello, back again. Here we are with the Newton universal law of gravitation. The gravitation between two planets, the sun and its planet, or any two objects in our normal life. The formula, as I already explained, is force of gravity equals g, that is the universal constant, times the two masses of the objects divided by their distance squared. Okay. In this video, what I want to touch base is how to move the formula around to get different things. For example, the formula right now is to get the force, and as you know, force is given in newtons. Now, but what happens if you do have the force, but you're looking for one of the masses? Okay? In order to get this, we have to move the formula around to leave one of the masses. Suppose that we are looking for mass 1, let's say the mass of the sun. So in this case, is first, the one that is dividing will pass to the other side. How does it move? By multiplying. So it will pass from dividing, multiplying in the other side. So we'll have force of gravity times the distance squared equals g and 1 and 2. And that will be it. The next thing is we want to leave alone m1. G and m2 are multiplying m1. So how do we pass them to the other side of the equal sign? Dividing. So we grab them and we pass them to the other side. Remember, when you pass something to the other side of the equal sign, it will pass divided as a denominator. So you will have fg times distance to the square divided by g m2. And that will be the formula for mass 1. Now, suppose that we have the masses of both celestial objects. We have the force between them, force of attraction or gravitational, but we are looking for distance. Okay? In this case, the distance is dividing back again, we pass it to the other side, multiplying, getting this formula. Force of gravity times distance squared equals g and 1 and 2. But is the distance the one that we want alone now? So, force of gravity that is multiplying will pass dividing to the other side. As I told you, because it's passing dividing, it will go as a denominator. So we'll have distance squared equals g and 1 and 2 divided by force of gravity. Now, there is a little problem here. We have distance squared. We don't want distance squared. So how do we get rid of the distance squared? We get the square root. So we will do square root of this one, and we get rid of the square. So final formula for getting distance will be the square root of g and 1 and 2 divided by force of gravity. Thank you for watching.